Hey there, I noticed several of you are having some difficulties making your own phylogeny, that is, tree of life, containing the observations you've made across many different taxa. And that's most likely because most phylogenies are just for a specific type of organism, like just protists, or just animals, or just plants, and they're all separate, and it's kind of hard to think about how they might all be together. So I'm going to draw for you one way you might represent a tree of life that incorporates many different taxa. So we'll start with Leuca. And Leuca is the last universal common ancestor. So that's the sort of ancestor of all living forms. And from that, we have a diversification of all different organisms. So I'm going to represent this diversification as kind of a spiral, like that. And the first group to come off of that would be bacteria. All right, so we'll put that down here. And bacteria, I'm going to try to use examples from perhaps your work, would include a group called Cyanobacteria, which is very common. Cyanobacteria make up the largest photosynthetic group on the planet, and very likely in any pond water sample or even some moist earth, you would find cyanobacteria as a component of that group. So that's within the domain bacteria. The next group to come off of this would be the archaea. And archaea, you probably don't have any members from, unless you happen to get some sort of a pond that has recently dehydrated down and become hypersaline and turned sort of a reddish color. Archaea includes things that are mostly extremophiles, can live in extreme salty conditions, temperature conditions, etc. Now, from an evolutionary perspective, the bacteria and the archaea have sort of recombined over time in different ways to produce a whole new series of organisms that we in general call the eukaryotes, right? So eukarya is the other domain. So three domains: bacteria, archaea, and eukarya. Now eukarya branches off all kinds of different groups. So I'm going to throw in a few, starting with the protists, which are the single-celled or primitive multi-celled organisms that very likely came about in about 1.8 billion years ago. Leuca was probably somewhere on the order of 3.8 billion years. And so 2 billion years of evolution gave us archaea and bacteria, and then very likely eukarya comes along at about 1.8 billion years. So let me just branch off a few of these groups. One is Archaeplastida, which is pretty common. And Archaeplastida has a bunch of different sub-branches that you're probably familiar with. One of them would be Rhodophyta. Probably you don't have any Rhodophyta. These are red algae. So that's one group, but if you're doing a marine system, you would have some Rhodophyta. Next, sort of in the list, would be Chlorophyta. And very likely, as I have seen, many of you do have Chlorophyta. These would be the green algae. And then coming along on this same branch from Chlorophyta is the group Plantae. And Plantae would have things like bryophytes and pteridophytes and coniferophytes and even flowering plants, which are magnoliophytes. And they would come off like this. So basically all of the sort of plants and things come off in this group from Archaeoplastida. And then some of you have something called euglenozoa, euglenids. And if you have those, they come off as a separate little group. And then some of you have things like ciliates, like a paramecium, for example, or you might have diatoms. And these are all in a large clade that's kind of referred to as the SAR group. And this includes alveolata, which includes the ciliates, and things like Stramenopila, which include things like the diatoms. Now I'm leaving off a few groups. For example, there's the rhizarians, which come off of this as well. And that would include things like forams, which you would only see if you were doing like marine systems. And then the next group to come off here are the uniconts, uniconta, and this would include the amoebozoans, things like amoeba. Things like slime molds, in case you have a slime mold. Some of you will this spring. Slime molds are awesome. And then sort of the last branch that I would put on here would be called Opisthocanta. And the Opisthocants, first branch comes off is a whole kingdom, the kingdom fungi. And then beyond that, really, are all the animals. And so you have two whole kingdoms here, fungi and animalia. And the animals, then, you could kind of peel off a bunch of different groups. But I'll just kind of throw out a couple to incorporate the things that you might have seen. And so there's eumetazoan and bilateralia, but really the main split that you guys have probably noticed would be sort of the deuterostome-protostome split. And protostome in animals. Sponges and things would come off before this, but deuterostome includes things like chordates. So if you have any birds, lizards, squirrels, whatever, they would fall into this group. And then the protostomes, for you guys, once again, there's two major groups. The ecdysozoans. And ecdysozoans are things that shed their outer skin when they grow. This would include nematodes. And it would include arthropods. And those are probably things you've seen, things like insects or whatever. And the nematodes, obviously nematode worms, something easily seen by you guys as well. The other group is the Lophotrochozoans. Trochozoans. They have a particular type of larvae. And coming out of this group include things like flatworms, Platyhelminthes. Some of you have those in your list. Rotifers. Some of you have those in your list. Annelids. And mollusks. These are all Lophotrochozoans, and they come off of that group. Anyway, so this is sort of a phylogeny made from the organisms most likely that you've seen. And it incorporates different groups and whatnot. I'm going to make a better one of these. I realized all of a sudden that I didn't have any different colored dry erase pens. So I'll be getting some and I'll make another one, but this should get you started. So there you go. Oh, by the way, all of the content of this I got from Campbell. So I looked up the phylogenies in different areas. So all the names like deuterostome and things like that, for example, I got right from the Campbell book. So let's see. Let me give you an example here. Protus 575. So here I am in Campbell. Boink. And I just look up, for example, in the Evolutionary History and Diversity of Life, under Protist, page 575, and I go there, and there's an explanation of the endosymbiotic events that I mentioned earlier, and right here is the phylogeny. They wrote it in a squared off sort of branching tree formation. I prefer the spiral one. But all the names I mentioned are right here in the phylogeny in Campbell. And so I've tried to use the terminology and the taxonomy from Campbell to create this. It's not something, you can use others. Any other taxonomy is fine. But just to make it more universal for all of you guys, since I know most of you have access to this book, that's the place I got all of the different names in here. Okay, well, hopefully that helps. Talk to you later.